Hello viewers, welcome to today's lecture on multiplexing techniques. In this lecture, we shall discuss various issues of multiplexing. First, we shall discuss why multiplexing, why do you really need multiplexing. Then I shall introduce to you the basic concepts of multiplexing, and as we shall see, the multiplexing can be divided into two different types: frequency division multiplexing and time division multiplexing. And as we shall see, the frequency multiplexing technique has two different variations, the frequency division multiplexing and wavelength division multiplexing. And the other one, the time division multiplexing, again has two different types, synchronous and asynchronous, which we shall discuss in detail. And finally, we shall discuss about inverse time division multiplexing, which is also in use today. And on completion of this lecture, the students will be able to explain the need for multiplexing, they will be able to distinguish between multiplexing techniques, they will be able to explain the key features of frequency division multiplexing and time division multiplexing, they will be able to distinguish between synchronous and asynchronous time division multiplexing, and explain the concept of inverse TDM. Why multiplexing? The observation, it is based on several observations. First one is, you will observe, it has been found that most individual data communication devices typically require modest data rates. For example, when you are sending voice, the data requirement is only say 4 kilobits per second, and obviously 4 kilohertz, that is the bandwidth. Of course, whenever you convert into digital form, then it comes to 64 kilobits per second. Then of course, that one is also not very big. And similarly, the data rate required, average data rate required is also not very high. On the other hand, the communication media usually have much higher bandwidth. For example, nowadays we can use coaxial cable, optical fiber, microwave link. They have several megabits per second, hundreds of megabits of bandwidth, and as a consequence, the communication media provide you much higher bandwidth. On the other hand, the users, individual users, have lesser data to send, and as a consequence, the two communicating stations do not utilize the full capacity of a data link. That means, if you have got two users, like say user 1 and user 2, say 1 and 2, and they are linked by a communication link, maybe optical fiber, coaxial cable, or whatever it may be, they are not able to utilize the link capacity fully. Another observation is that the higher the data rate, the most cost effective is the transmission facility. For example, if the data rate is small, then the cost per byte or per kilobyte is more, and if the capacity is large, say several gigabits, then the cost per byte or cost per kilobyte is much less. So that means, if we use a link of higher capacity, then we get it as a much lower cost. So that is the observation. So based on this observation, it has been found that we can use a technique known as multiplexing. How we shall explain. When the bandwidth of a medium is greater than individual signals to be transmitted through a channel, a medium can be shared by more than one channel or signals by using multiplexing. Essentially, what you are trying to do, we are trying to share the channel capacity or bandwidth of a particular medium by several signals, by several users, and for efficiency, the channel capacity can be shared among a number of communicating stations. That means, we have to utilize the channel fully, channel capacity fully, and for that purpose multiplexing can be done. And as you know, most common use of multiplexing is in long haul communication using coaxial cable, microwave, and optical fiber. As you know, for long distance communication, normally we use optical fiber. or a terrestrial microwave or satellite microwave or optical fiber, and all these transmission media have high bandwidth, and these are to be shared by using multiplexing. I shall start with a very simple example. If in a telephone line which has bandwidth of only 2400 hertz, which is used for data transfer between two stations, and as you can see, we can divide it. If your data rate is small, which can be satisfied by say 1200 hertz, then you can divide it into two parts, say half 1200, so 600 to 1800, and another is 1800 to 3000. Then what can be done? The 1200 can be the first 1200 can be used to transfer data from say user A to B, that means in one direction, and the other one can be used for transfer of data between from user B to A. So, what you can do, you can achieve bidirectional data transfer with the help of a single channel, and only thing that we have to do, divide the bandwidth, and one part is used for one direction of data transfer, and that can be done by using multiplexing. For example, we can use frequency division multiplexing, FDM, or and in detail we shall discuss about it in more details later on. Let us see what is the basic concept of multiplexing. What we do, we use a device known as multiplexer, and which combines signals coming from n channels. Here you are getting signals from n channels 1, 2 up to n. Signals coming from n channels are combined together and sent through one medium. As you can see, you have got only one medium, and so n channels signals coming from n channels are combined to send through a single medium, and at the other end what we are doing, there is a demultiplexer, and the demultiplexer is performing the reverse operation. It is separating out the signals coming through a common channel and sending to n different channels, as you can see 1 to n. So, this is the basic operation. So, you require a multiplexer and a demultiplexer. So, this multiplexer and demultiplexer does the operation of combining and separating out.